Alright guys, welcome to this page of the notes, and like I said before, what we're going to do is a couple more proofs, but these ones are going to be two-column proofs, which we've actually been working with since way back in chapter 1. Hopefully at this point you're getting a little bit more comfortable with doing two-column proofs. We'll do a couple more here again just to sort of reinforce that idea of how these go. So the first one, here's what I want you to do. You're given that the measure of angle 1 is 90 degrees. I want you to write a two-column proof to show that the two lines intersect to form a right angle. That means they are perpendicular and that they intersect to form four right angles. So you're going to prove to me that angle 1, angle 2, angle 3, and angle 4 are all 90 degrees. All four of them are right angles if one of them is 90 degrees, right? If one of them is a right angle, they all have to be right angles. That's what we're going to prove. So here we go. Let's just jump right into this. I apologize. I'm going to have to write kind of small, and I'm going to have to use a little bit of shorthand because I don't have a whole lot of space. So just stick with me. I'll say the full justification, but shorthand it here. So here's what we know. First of all, I know that the measure of angle 1 is 90 degrees. How do I know that? Well, it's given. Okay, now, because of that, here's what I know. I know that the angle 1 and angle 2 are a linear pair. Now, how do I know that? Again, look, it's given to me. So that is also given. Now, because they're a linear pair, I know that angle 1 and angle 2 are, here's my first abbreviation, are they're supplementary angles. Angle 1 and angle 2 are if they're a linear pair, then they must be supplementary. They have to sum to 180 degrees. And again, that would be our linear pair theorem. Linear pair theorem, right? So based on our linear pair theorem, right, if I have a linear pair sums to 180 degrees. That is the linear pair theorem. So they're supplementary. Now what I can then do then is say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, that's our definition, right? That's our definition of supplementary angles. So it's our definition of sup angles, right? Our definition of supplementary angles says two angles sum to 180 degrees. No big deal. But now, here's what I know. Look, the measure of angle 1 is 90 degrees. So we're going to do a quick substitution. 90 degrees plus the measure of angle 2 is 180 degrees. Guys, that's a substitution. I'm just simply substituting the measure of angle 1 for the measure of angle 1. Well, subtract that to the other side. The measure of angle 2 is 90 degrees, right? That's the subtraction property. I subtract the 90 to the other side. Forgot my C. Subtraction property. Okay, awesome. So here's what I've done. I know the measure of angle 1 is 90. I have now just shown the measure of angle 2 is 90 degrees. Okay, so keep going. Here's what I know. I know that the measure of angle 2 is congruent to the measure of angle 4. How do I know that? How do I know that the measure of angle 2 is congruent to the measure of angle 4? Vertical angles. Do another substitution, right? The measure of angle 2 is 90 degrees, which must be equal to the measure of angle 4. So there we go. I have just shown, based on a substitution, right, shown that the measure of angle 4 is also 90. So here's what I've done so far. Measure of angle 1 is 90. I've proven the measure of angle 2 must also be 90. I've proven the measure of angle 4 must also be 90. We're almost there. Look, look, look. The measure measure of angle 1 is congruent to the measure of angle 3. How do I know measure of angle 1 and angle 3 are congruent? Vertical angles. So, do the substitution. Right, I know the measure of angle 1 is 90 degrees. Plug it in. And that's a sub. Again, I know, I apologize. I had to squeeze. I know that's really tight. Also, I apologize for the abbreviations to get it all to fit, but here's what you did. I told you that the measure of angle 1 was 90 degrees. It was a right angle, and I asked you to prove then that all of the angles must be right angles. That's exactly what you did. You just proved that the measure of angle 2 has to be 90, the measure of angle 4 also has to be 90, and the measure of angle 3 must also be 90 degrees. So if you're given one angle is 90 or a right angle, you know that all of the angles are 90 degrees or right angles. All right, here we go. I got another one for you. Slide on up once again. I apologize. I'm going to have to squeeze a little bit here, use some abbreviations, but here's what I want you to do. Given the measure of angle 1 equals angle 2, please notice, right, this single arc, that tells you that they're congruent. So they are, right, congruent angles. I want you to do a two-column proof to show the two intersecting lines form a linear pair of angles with equal measures, and that these lines are perpendicular. Okay, great. Well, we'll always start with what we're given. So, angle 1 and angle 2 are a linear pair. Right, how do I know that the measure of angle 1 and the measure of angle 2 are a linear pair? Well, that's because it's given. Sorry, hang on, I wrote way too big. Wait a second. Let's go a little smaller. Angle 1 and angle 2 are a linear pair. That is given. Okay, great. Now, here we go. Because angle 1 and angle 2 are a linear pair, again, that exact same thing, I know then that the measure of angle 1 and angle 2 have to be supplementary, right? If they're a linear pair, they must be supplementary angles. Are sub. I know that they're supplementary. Again, that's our definition of a linear pair. Definition of linear pair, right? So definition of linear pair tells me those guys have to be supplementary. Oh, hang on, what does supplementary mean? It means they add to 180 degrees. So angle 1 plus angle 2 equals 180 degrees. That is our definition of supplementary angles, right? The definition of supplementary angles is that they sum to give you 180 degrees. We're almost there. Check this out. The measure of angle 1 is equal to the measure of angle 2. Guys, it was given to me. So that's another given. Now, what that means, right, is I can do a substitution, right? If the measure of angle 1 plus the measure of angle 2 is 180 degrees, and I know that the measure of angle 1 is equal to the measure of angle 2, substitute, right? I can plug m, measure of angle 1, in for the measure of angle 2, because they're equal to each other. So here we go. I have the measure of angle 1 plus the measure of angle 1 equals 180 degrees, right? I'm just going to take this right here, substitute that in. That's a substitution. And now let's do a little bit of algebra. We're going to combine like terms. So 2 times the measure of angle 1 is equal to 180 degrees. That is simplifying. Right, I simplified. I simply combine like terms. Divide the 2 to the other side. So the measure of angle 1 is equal to 90 degrees. Equal to 90 degrees. That is the division property. right? The division property says that I can divide a 2 from both sides. Well, now that I know that the measure of angle 1 is 90 degrees, right? What do I know? Well, if that is 90 degrees, then that means that it is a right angle, which tells me that L and M must be perpendicular. So, because the measure of angle 1 equals 90 degrees, angle 1 is a right angle, and therefore L is perpendicular to M. Which is what I wanted you to show. I want you to show the lines are perpendicular, which is exactly what we did. We proved L and M are perpendicular by showing that the measure of angle 1 was 90 degrees. And if I know if angle 1 is 90 degrees, thanks to the proof above, 2's got to be 90, that one's got to be 90, they all have to be right angles. All right, guys, thanks so much for joining me for this set of videos. Again, I know sort of the recap here of what we did is we did the perpendicular bisector theorem and its converse, which really isn't a difficult theorem. It just simply says if you have a perpendicular bisector, any point on that perpendicular bisector is equidistant from the endpoints. And then we just got a lot more practice here with doing proofs. Again, if this were an honors geometry class, you should be, at this point, we've done these enough times, able to construct a 2-column proof on your own from scratch, doing your steps and the justification. In a geometry class, I give you the bones of the proof and you just have to plug in the missing pieces. Guys, I had a really good time talking about perpendicular lines with you. I'll see you next time.